So a lot of you really liked my last LeetCode with me session where I shared how I do LeetCode in real life, including all the mistakes and kind of just my process. So today we're going to do another one. As I mentioned last time, most LeetCode videos will walk you through the clean, polished solution, which can be really helpful, but knowing how to get there on your own is the real skill. And that's what I'm going to be showing you today. So let's get into it. Let's start with the daily question again. Given a word list, we want to implement a spell checker that converts a query word into a correct word. For a given query word, the spell checker handles two categories of spelling mistake: capitalization and vowel errors. Okay, so capitalization is basically we have a certain capitalization of a word, and we want, if the word kind of is the same, but the capitalization is wrong, we want to match it. And then we have vowel errors. Okay, so then if any of the vowels are wrong, we can match those. Okay. In addition, the spell checker operates into the following precedence rules. When the query exactly matches a word in the word list, you should always return the same word back. Oh yeah, and we have a word list, so there's not necessarily just one word. So you should return the first word that matches capitalization. Okay. Let's get our comment template. This is something I like to paste into whatever LeetCode problem I'm solving to kind of take notes as I go along about my thinking. Kind of my approach is thinking through everything in English, understanding everything when I write in code before writing a single line of code. And this comment template really helps me, take notes on that. So my first thought is our brute force solution would be convert everything into lowercase. So both the word list and the query. Or actually, yeah. Oh yeah, we have hold on a minute. Let's understand the problem a little bit better, particularly our input. So we have a list of words and a list of queries. We need to look at the examples. So if we have a list of words and a list of queries, our output is going to be the same length as the query list, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, okay. And so for each item in the query, we have an item in the output. And each item in the output exists in the word list. Okay, so now let's think about our brute force solution. We'll have a for loop for the entire query list. So for each thing, or for each query, I should put on do not disturb. There, now it won't disturb me. So for each item in the query list, we want to see if it matches with any word in the word list. So that is going through the queries O of n, and then going through the word list is, let's say the word list is of length m and queries are of length n. So then going through that would be O of n times m, the complexity for seeing every combination. But then when we are checking, how do we actually check? We could first put both the word and the query into lowercase, see if that matches up. If it does, we add the originally capitalized word, not the query. And then if not, we can replace every vowel with a placeholder and then see if those two are the same. That's my first thought. If we can have the query have any wrong vowels, then it doesn't really matter what vowels it has or what vowels the word has. Okay. So that would be our brute force. We would have to go through the length of the string, lowercase everything. Okay, now here's a question. Do we need to do them in separate steps? Oh yeah, right. So we actually want to go through each of these steps for the entire list rather than just each individual word. Because if we have a word that matches to the capitalization, we want to find it before we start trying to replace vowels. So that means that we have to go through the word list, worst case twice. right? And then every time we compare, we have to go through the entire string of both of them. Okay, at this point, I'm a little bit confused because in terms of the time complexity, because we're dealing with so many different lengths, so we have the length of the word list, the length of the query list, the length of each of the strings in the word list and the query list. Obviously, knowing the time complexity of this is not crucial for solving it, but I really like to be thinking of the time and space complexity as I go along, just because it's really good practice to kind of really understand what your code is doing. And also, if you're ever on an interview and you are asked, what is the complexity of your solution? Even if you just say it yourself, it's bonus points. They really like to see that. So as I'm going through these LeetCode problems, I like to really understand what the time and space complexity is going to be. So I'm not sure, honestly. And I'm going to actually go ask ChatGPT. Yeah, that's what I was saying pretty much. So we have 3 different kinds of variables. So the length of the word list, length of the query list, and the word length, maximum word length. So I didn't think about the fact that the words in the word list and the queries are related, considering that we are trying to find them to be matching up, and they can only match up if they're the same length. That's actually a good point for actually solving it. So the first thing we can do is compare the lengths, and if they're not the same, then there's no way they can match up. But then, yes, that would be our time complexity. That's about what I was saying. Okay, so at this point, should we implement the brute force solution, or should we try to make it better? How can we make it better? Nothing's really coming to mind right now, so I'm gonna try implementing it. Our approach is gonna be to loop through the queries, and for each query, first take a pass through the word list, see if the capitalization matches up. If not, loop through the word list again, see if the vowels match up. Oh, and of course, first, compare the length. Oh yeah, and our time complexity is gonna be complicated of n times m times l, and our space complexity, we're not using any extra data structures, so it's gonna be just O of 1. I don't remember. How do you do lowercase in Python? I'm going to look up the syntax. Okay, so I was on the right track. Wait, is it break or is it continue? I think it's continue. Okay, right, it's continue. We don't want to break the for loop. Right, so if it's not the same length, go to the next word. If it's not the same, ignoring capitalization, I can't type, then continue to the next word. But if it is, this is probably not the best syntax to write this. So how about if it is the same length and it's the same when it's lowercase, then we can say that it's added to our result, right? So we want a result. And we're going to append the word, not the query. And we want to have a flag for if we found the word for the query. My first way of thinking of how to do this. We append, and we also don't want to do this for loop anymore. But yeah, we say found is true. And then we also want to this for loop. Else, nothing. If not found, then we go on our second pass. So, okay, we're just going to say vowels, and here we're doing capitalization. So we want to first replace the vowels. So what can we replace them with? What do we not have in there? Are we allowed to have numbers in here? Okay, yes. So we only have English letters, so we can replace them with, let's say, 0. Now, strings aren't as easy to just replace as arrays. So we're gonna go with new W is gonna be, I think this is where it would be helpful to define our own custom function for anonymizing vowels. Let's get our vowel list. Actually, let's go with this. I think that'll work. Let's see. And then we can do the same thing for our word or our query. Oh yeah, and we want to do this. Actually, what did we call our query? Q. And then if they are the same, then we're gonna add them. This feels very, very brute force, but let's see if it works. Oh yeah, and then we want to say found is true, because then at the end, we will want to say, if still not found, append just an empty string, right? Yep. Oh yes. Wait, what? Oh yeah, anonymized vowel, whatever. We'll call it that. Okay, list has no attribute to join. Oh yes, the other way around, forgot. Okay, we can't just return an integer like that. This is why I prefer type-safe languages, but I like the simplicity of Python for LeetCode. But for actual projects, type safety all the way. And like strongly typed languages, I definitely prefer. Aha! So we actually want to do 3 passes through because there might actually be a word that matches up exactly. And that's what we want to return instead. Okay, so we'll do exact match first. We'll check our length there. Oh yeah, and here we actually can like not even worry about it and say I feel like this is not that good of an optimization, honestly. Let's just get rid of it for now. And then we want to say only if we haven't found it yet. Okay, so that's correct now. Let's see how our runtime and stuff is. Oof, that's brutal. Gotta love it when your solution sucks so much that you get a time limit exceeded, not just a horrible position on the bell curve. Okay, so we have an extremely long word list. Oh gosh. And we have an extremely long query, and it looks like all of them are 4-letter words. Now, was there some sort of constraint that said that they were going to have the same length? I don't think so. No, so there was nothing that said they're going to be the same in the constraints. So the word in the word list is at least 1 character, and the word in the query is at most 7 characters. Obviously, n times m times l is not ideal, so I'm gonna go ahead and look at the topics, see if that'll give me a hint. I like to do that. Okay, array hash tables. How can we use a hash table to help us here? So my first thought would be we can like anonymize that word. So, put it all lowercase and replace all the vowels, and then look up each word that way. If we were to use a hash table, what would be our keys and what would be our values? Our key, I just had a light bulb moment. Our key could be that anonymized version. And then our value could be an array of the words from the word list that correspond to that key. Okay, we're going to start a new section, I guess. So what we would do is we would go through the list and we would hash anonymize the thing with, putting it to lowercase and replacing all the vowels, the word list, make a new key and put that as the value. If it already exists, then append it to the value. And then after that, we can go through the query list, hash that query, and then we have to look through a much smaller list of word contenders. Okay, I'm feeling like this is a really good optimization. Let's think about it. So the complexity would go down to, we would have to go through the word list and go through the length of each one, which would be O of n times L, and then we have to go to the query list, which would be O of m times L. So it would be O of n times L plus, which is already a lot better. Because if we don't think about the length of the string, then it's just O of n plus m. But now our space complexity does go up. We're storing every single thing in there anyway, so it's O of n, where n is the length of the word list. So we can still use our anonymize. In this case, however, we have we'll call it a lookup. We go through the word list first. So we're going to hash it. Okay, then we go through the query list. So then we want to look through, oh yeah, so first there might be possibility that this is not in the lookup. So if hashed not in lookup, then we have a result, nothing. Otherwise, we're going to look at this array right here. It's going to be an array, right? So we're going to say for word in there, we're going to look at, oh yeah, so then here is where we go through our 4 steps. So first we go through, oh man, I wish I hadn't deleted that. Oh well. So first we go exact match, then we go capitalization, and then we go the vowel if syntax error there. Okay, and then the only way that we are looking at it otherwise is if it's only matched up by the vowels. Or you want to have a flag again. And we want to break. And then if we still not found, then yeah, I'm rewriting everything from what I already had. And then last of all, if it's still not found, then it's just the first thing, I think, that works, right? Yes, so then it's just the first element of that array. And then at the end, return our result. Did it work? No, because there's something wrong with my syntax. Interesting. So that did not work at all. Why not? So if it's exact match, obviously it works. It only works for now is if it's the exact match. Oh, it's because our anonymized function is per character, not per proper word. We're going to say that's the hash function. Oh, I should not have deleted it. So dumb. Okay. Yeah, don't delete your code maybe. Just, you might need to use it later. Okay. So we want to return but I guess it's good practice to type it all out. Indeed. Well, I'm sorry for just having simple syntax errors. Okay, there we go. Now it works. Now let's see if we can at least get it to pass through. Okay, we at least got it to pass through. We're very good on memory. What on earth is this? Oh boy. It's not that bad. Truly, it's not that bad. Okay, we're gonna try again just to see if this was a fluke. I thought it was really smart. What did I do? Where did I go wrong? You know what I bet it is? I bet it's some like very small thing. It's not even the approach. It's just some small thing that I'm doing wrong. or like not optimally, suboptimally. I wonder how much of a difference it would make if I wasn't looking this up multiple times. I'm just curious if this makes any difference. It made some difference. I doubt it's anything though. Margin of error is huge on these. Sometimes like I don't like the margin of error on these LeetCode problems, because then you're like, oh, well, did I actually do better, or is it just a stroke of luck? Okay, the fact that I am at 461 milliseconds of runtime while people are like doing 35 is probably not a small optimization. I bet you it's all the messing around I do with these. What if I don't use a list comprehension? Will that make a difference? Watch this. No, oh yeah, it's returning. Again, literally no difference. At what point do I just look up what other people did? Okay, I'm gonna look at the hint. There's no hint. Damn. Okay, fine. You know what? I solved it. So I am going to look at what other people did that was better. Okay, so they had an optimization where they looked at the perfect words. Okay, so they had separate dictionaries. Okay, so yeah, if you have separate dictionaries, that will take up much more space, which is very much reflected on how well I did on memory. So I probably need to take up a little bit more space in order to get an optimal result. Yeah, I can see that how like if we have multiple different dictionaries, we can really cut down on the time, because then we don't have to go through that list 3 times or twice at least. So yeah, let's try that. Perfect. We have a set of all the words. Then we have cases. Then it's going to be a dictionary. And then it's going to be vowel. Okay, so the first thing we want to do is just do the lowercase. Okay. If Q in perfect, we can just append that to the result. And continue this for loop right here. Else, if Q lower in cases, then we return the first word that matches that. So append cases, Q lower. We're only ever getting the first one. Do we really need to have a list? I don't think we need to have a list. Let's try it without a list. Wait, we don't have lookup anymore. We have vowels. In vowels, finally, all right. Oh yes, and at the end we return the result. So this seems like a lot fewer iterations through things. Let's see. Yep, syntax stuff. Look at that. That is a lot better. And I'm going to indulge myself in trying again to see how much of a margin of error we have. Okay, yeah. This was a medium problem, and I felt like I took a lot more time than I thought I should. Honestly, I haven't been doing LeetCode often enough, but I feel pretty happy with the result here. So, shall we do another one? Maybe an easy one to finish off with? Something random. Easy. There we go. Okay. Given an array of distinct integers, find all pairs of elements with the minimum absolute difference of any two elements. Return the pairs in ascending order with respect to pairs. Each pair A, B as follows. A, B is A is less than B, and B minus A. Okay. So in here, 1 and 2 have a difference of 1. 2 and 3 have a difference of 1. 3 and 4 have a difference of 1. All of these pairs have a difference of 1. In here, 1 and 3 have a difference of 2. 1 and 6, so ones have more. Okay, so basically we just, pretty straightforward. So the brute force solution here, absolute simplest, would be check every single pair. That would not be optimal because we'd have to be storing a lot of things as well as O of n squared. So what would be better is to have the array sorted. Then we only have to make one pass through the array. So the sorting itself would be n log n, after which the pass through would be O of n. So our time complexity there would be O of n log n. First we're gonna sort. Then we're gonna compare the pairs that are next to each other. We're gonna store a minimum difference and store the pairs of that minimum difference. If we find that we found a new minimum difference, we're going to clear our array where we have all the pairs. Okay, that's pretty straightforward. We can just go ahead and start coding that. So of course we have a time complexity of n log n due to the sorting, and the space complexity of worst case O of n, because it's worst case something like this, where every single element in the array is increasing by the same number. So there's a big list of pairs that are the same difference. But worst case, there's going to be n minus 1 of those pairs. Yeah, pretty straightforward. Let's start doing this. Okay, I'm going to sort the array. Then, did we think about any edge cases that we missed? Okay, array length is at least 2, so there's always going to be something. I think we're going to iterate through starting with 1 so that we can look at the previous one and the current one and compare those two. Yeah, we need a minimum. So do we have duplicate numbers in the array? Okay, distinct integers. No, we do not have duplicates. I always hate when I try to name my variables with keywords that already exist. And that's why I fall into the bad practice of naming my variables with one character, which isn't great, but minimum, I feel like it makes sense. So minimum is 0, but it will never be 0 because it's distinct, so it's fine. No, wait, it's the other way around. We always want the minimum to be decreasing, so we want it to be infinite. Our minimum is infinite. And then our result is going to be a list. And that's where we're going to store our pairs. So if that minus that is smaller than the minimum is going to be that. And we're going to clear our result. Otherwise, that is equal to the minimum, then we append to the result our current pair. So, and when we have a new thing, we also want to do that, actually. Otherwise, we don't care about that pair. Why is it out of range? It's because we have to do this. Okay. It's not getting the middle pair. Why is it not doing that? So in theory, our array is sorted, right? So it's 1, 2, 3, 4. Starting from 2, if 2 minus 1 is less than m is now 2 minus 1. So 1 result, we append that. 3 minus 2 Why on earth is it not getting appended? Okay, at this point, I've been staring at it and I don't really know what's wrong with it, so I'm gonna copy it into VS Code and put in some print statements. All right, this is where I'm gonna turn off Copilot. When I do LeetCode and I'm doing it in VS Code for one reason or another, I like to disable AI just so that, you know, I'm doing it authentically. So we're gonna say we're comparing why is it doing that? I'm never reassigning I. Why is it? So it's only doing 1 and 3. Oh my god, I'm an idiot. You're telling me this entire time I forgot to just type in RANGE? I'm clearly very tired right now. Can you tell? There we go. Well, that was easier. Okay, well, I think that's a wrap for today. If you enjoyed watching me LeetCode or found this helpful, drop a comment. If you're new here, I'm a computer science student. I'm sharing my journey to becoming a software engineer here on this channel, so if that's something you're interested in, feel free to stick around.